Here we are going to compute the trace of the given 5 matrices. The trace of a matrix is denoted in this manner. So for the trace of A, the trace of B, okay, the trace of C, the trace of matrix D, and the trace of matrix E. The trace is equal to the sum of all the entries in your diagonal. Okay? Yeah, we're going to add the entries in our diagonal, but here's the catch. There's the trace can only be computed for a square matrix. In short, an n by n matrix. It could be a 2 by 2, 3 by 3, 4 by 4, etc., etc. If the matrix is not a square matrix, automatically the trace is undefined. We're talking about the trace of A. Since this is matrix A is a 3 by 2 matrix, this is not a square matrix, so the trace is undefined. This goes as well to your C. Your C is a 2 by 3 matrix. It's not a square matrix. In short, your trace is undefined. But for B, D, and E, we can create or we can compute for the trace. Because B is a 2 by 2, your D is a 3 by 3, and this is also a 3 by 3 matrix. Okay? So for B, the trace of B, we're just going to add the entries on your diagonal. So the trace of B is 4 plus 2, so the trace of B is equal to 6. The trace of D is again the sum of the entries in your diagonal. So you have 1 plus 0 plus 4. So the trace of D is computed as 5. And finally, for the trace of E, you add these entries here. You have 6 plus 1 plus 3. The trace of E is 10. So again, the trace of matrices is the sum of all the entries in the diagonal, given that the matrix is a square matrix. And if ever you're also trying to compute the trace of the resulting matrix of an operation, make sure that you check first the operation, whether it will result into a square matrix. Then if it's not, no need to compute for the operation. If the question is just trace, then simply declare undefined. But if it's a square matrix, so compute or subject the matrices in the operation. Given that the result is a square matrix, add the resulting entries in your diagonal, and that's your trace. Thank you for watching.